Hi guys, so today we're going to do some more Algebra 2 review. Today we're going to look at long division and synthetic division for polynomials. So before we do long division of polynomials, we need to review how to do long division with actual numbers. So what I want you guys to do is actually just divide 31,272 by 5 using the long division process like you learned back in elementary school. So 5 goes on the outside, 31,272 is on the inside. So we look and see, does 5 go into 3? It doesn't, so we look and see, okay, 5 goes into 31 6 times. Then the process that we do from here is the same thing that we'll do with polynomials. I do 6 times 5, I write it below, I subtract, and then I bring down the next number. And then I do it again. 5 goes into 12 2 times, 2 times 5 is 10, subtract, and bring down the 7. Do it again. 5, 25, subtract, and I get 4, and I get a remainder of 2. Now, what you can do here, some of you guys may have learned you put the decimal and then the 0, and then you bring that down, and then you keep going, which is definitely something you can do. Some of you may have just wrote remainder 2, but what you actually can do is write the remainder as a fraction over the divisor, and that's how we're going to write our answers here. So the correct answer here is 6,254 and 2/5. Now, if you wanted to, you could put that 0.0 and bring it down, and I would get 0.4. And if you know, 0.4 is the same thing as 2/5, so it's the same thing. But this fraction concept we're going to use here in a second with polynomials. So what we're going to do is the exact same process, but we're just going to look at a polynomial. So I'm going to take x squared plus 3x plus 1 and keep it on the outside. And then I'm going to put 4x cubed plus 2x squared plus 3x plus 5 on the inside. Now, to make this process a little bit easier, we don't need to find the number that we're going to write at the top doesn't need to be what this whole thing divides into to get this whole thing. That's not going to work. That's going to be too hard. So all we look at are the first terms here. Okay, so I'm looking at just x squared and 4x cubed. So what I'm going to put up here at the top is something times x squared that gives me 4x cubed. Okay, well, x squared times 4x would give me 4x cubed. Now, I can put 4x here, but I'll tell you guys just the way that I usually write it. I like to keep all of the like terms in a row or in a column. So I'm going to put 4x above 3x. That way all of my x's are together, all my squareds are together, all my cubes are together, okay, keeping everything in the same row. Now we're going to follow the same process that we did back in regular division. I'll take 4x and I'll multiply it by everything on the left side. So 4x times x squared is x cubed. 4x times 3x is 12x squared. 4x times 1 is 4x. Then if you remember, the next step is to subtract. And this is where there's a lot of mistakes. Because what a lot of people do is they write minus, but they forget that that minus applies to all of those terms. So what I do instead, it is minus. I go ahead and I change it to plus, and I change all of my signs. That way we're adding, and it's a little bit easier to remember it's going to apply to everything. And a teacher who used to teach Algebra 2 here would always use the expression, you draw the line and you change the signs. And that's what I'll probably be saying here too. So we should get 0 here. That's why we picked the number that we did. Okay, 2x squared plus a negative 12x squared is a negative 10x squared minus x plus 5. And then we do the whole process over again. We look at just the first terms. So x squared and minus 10x squared. So x squared times something is a minus 10x squared. Well, that something is a minus 10. Then I take minus 10 and I multiply it by everything over here on the left. So negative 10x squared minus 30x minus 10. And I'm going to subtract. And then when I draw the line, I'm going to change my signs. So this becomes 29x plus 15. And at this point, you'll notice x squared isn't going to go into 29x. So at this point, what we have is the remainder. We write the remainder as a fraction over the divisor. So my final answer would be 4x minus 10. And then I write 29x plus 15 over x squared plus 3x plus 1. So that's how I write my remainder. You'll know it's the remainder when it's a lower degree than what you have over here as your divisor. All right, let's try another one. So again, let's get this set up correctly. x squared plus 2x minus 5 on the outside, 6x to the fourth plus 5x cubed. And if you'll notice, there's no x squared here. I'm going to go ahead and fill in a plus 0x squared just to make this a little bit easier to keep everything and all of my like terms lined up. That's going to be a really important step when we do synthetic division here in a minute. All right, so now let's look at the first terms. X squared times something is 6x to the fourth. Well, x squared times 6x squared is 6x to the fourth. Once you have the number at the top, you multiply it by everything on the left. So that's 6x to the fourth plus 12x cubed minus 30x squared. And we're going to be subtracting those, but when I draw the line, I'm going to change my signs. All right, now we can add. So negative 7x squared plus 30x squared, bring down the next number, and we do it again. First terms. So I have made a mistake. That was a cubed, which means that's a cubed. Sorry about that. We do it again, though. Okay, we look at the first terms. X squared times something is a negative 7x cubed. Okay, well, x squared times a negative 7x would be negative 7x cubed. So then I take that negative 7x and I multiply it by everything over here. So negative 7x times x squared, negative 7x times 2x, negative 7x times 5. All right, now we're going to subtract. And when I draw the line, I change my signs. And then let's combine these. So I've got 44x squared minus 35x. Bring down the plus 8, and we're going to do it one last time. Okay, let's look at our first terms. So I've got x squared times 44 would give me 44x squared. So then 44 times everything on the left, 44x squared plus 88x minus 44 times 5. And then draw the line and change the sign. So change my signs. So then this becomes 35 minus 88, or negative 35 minus 88, which is a negative 123 plus 228. And as I'm doing this, I'm realizing I made another small mistake on here. This is why we show our work. Sorry guys, I keep getting cut off by announcements and different things, but I realized I made a small mistake up here. When I did 2 plus a negative 35, that should not have stayed negative 35. That should have been a minus 33, which is going to change this to the correct answer of minus 121. All right. So again, the way we write our answer, we take what's at the top, we take our remainder, we write our remainder as a fraction over the divisor. All right, if you feel comfortable, pause the video and try this next one on your own. All right, so let's get this set up. I've got 2x cubed minus 10x squared plus x minus 5. So again, I'm going to look at the first terms. So x times 2x squared is 2x cubed. Multiply it by both of those. Draw the line and change our signs. So that ends up being 0. All right, well, let's bring down our x. So if I go ahead and do this, I'll go ahead and bring down my minus 5 as well. X times 1 is x. If I multiply that, draw my line and change my signs, I get 0. So this one actually works out perfectly with no remainder. So I get 2x squared plus 1. Now, what we're going to do on this one is actually the same exact question using synthetic division. So you may remember synthetic division from Algebra 2. It's a little bit faster than long division. The problem with synthetic division is it doesn't work all of the time. Synthetic division only really works when you're dividing by something like x plus or minus a number. That's when we want to use synthetic division. So we're going to do the same problem using synthetic division. So the way it works, we're going to take a number and we're going to put some number in the top left up here in a little box. So that number is the 0 of the factor. Okay, so if x minus 5 is what we're dividing by, positive 5 is what goes in that little box. Then what we're going to do is we're going to write the coefficients of all of the terms that we're dividing by. So the coefficients would be 2, negative 10, 1, and negative 5. Then our process here, what we do first is we start by bringing down the first number. Then we're going to do the same thing over and over again until we get to the end. We take the bottom number, we multiply by what's in the box, and we're going to write that in the next available space. So 2 times 5 is 10. Then we're going to add down the column. Then we do it again. 0 times 5 goes the next available spot. Add down the column. 1 times 5 in the next available spot, add down the column. Now our answer here, okay, it should be the same as what we just got. It's the exact same problem, and it is. So we need to understand what these numbers in our answer actually mean. The last number, that is your remainder. Okay, the last number is the remainder. The other numbers are the coefficients of the terms in your answer. It's going to start one less than the original problem. So my original problem was 2x cubed. So my answer is going to start one less than that, which would be x squared. Then I would have x, and then I have 1. So I end up with the exact same answer that I got in the previous question. All right, let's try another one with synthetic division. So if I'm dividing by x minus 2, positive 2 goes in my little top left. Then I write my coefficients. But again, I need to be careful and make sure there are no skipped numbers. So if you notice, there are not any x squareds listed. I have to fill in the 0 for that x squared. All right, so then I have 2. I have 0, negative 5, and 8, and those are my coefficients. Then I'm going to go through this process, bring down the first number. Then we're going to do the same thing over and over. The bottom number times the number in the box, write it in the next available spot, add down the column. Bottom number times the number in the box, next available spot, add down the column. Multiply, add down the column. And then again, we have to know how to write our answer. The last number, that's the remainder. Everything else, we start 1 degree less than the original. So the original was x cubed. So we're going to start with x squared and then x. So this would be 2x squared plus 4x plus 3. Our remainder is 14, so we write that as a fraction over the divisor. All right, if you feel comfortable, pause the video, try this next one on your own. All right, negative 1 goes in the box. Okay, it's the opposite sign. It's the 0 of that factor. Then I write my coefficients. 2, there's 0x cubed, negative 4, 2, negative 3. All right, bring down the first number, multiply by what's in the box, add down the column. Multiply by what's in the box, add down the column. Multiply, add, multiply, add. The last number is the remainder. So remember, the way we write this, we start 1 degree less than the original. The original was x to the 4th. So this will be x cubed, squared, and x. So 2x cubed minus 2x squared minus 2x plus 4. Write the remainder as a fraction over the divisor. All right, so synthetic division, like we said, it's a little bit easier, but it doesn't work all the time. Synthetic division really only works when you're dividing by a first degree binomial. So if you're dividing by x minus 2, if you're dividing by x plus 6, okay, that's when we want to use synthetic division. Then some interesting things about synthetic division. The remainder is the same as evaluating f of a. And if the remainder is 0, the divisor is a factor. Now that's an idea we're going to use here in a second and use a lot next class. So let's recap some of the things we talked about whenever we're doing the graphs. If 5 is a 0 of a function, then x minus 5 is a factor of that function. So that means that if I were to evaluate, that should be the same letter. Sorry about that. That should be p. Okay, if I were to evaluate p of 5, it should equal 0. And then when you do synthetic division with 5 in the top left, the remainder will be 0. All right, if negative 3 is a 0 of p of x, this is what we did last class. If negative 3 is a 0, x plus 3 is a factor. And again, that should be a p. Okay? So if I do p of negative 3, okay, that should equal 0. If I plug in negative 3 for all my x's, I should get 0. Okay, that means it's a 0. Now the synthetic division part, if I do synthetic division with negative 3 in the top left, the remainder is going to be 0. And that's a lot of words, but let me show you how we're going to use it. So this tells us that 3 is a 0 of this polynomial. Okay, that means that this graph is going to cross the x-axis or touch or bounce at the x-axis at 3. So what we're going to do is we're going to do synthetic division with the number 3 in the box. So let me write my coefficients. All right, I'm going to bring down my first number. I'm going to multiply, I'm going to add. I'm going to multiply, add, multiply, and add. And I get 0 as a remainder. So what I just did was I proved, yes, 3 is a 0. If 3 is a 0, x minus 3 is a factor. But our goal here was to factor this completely. So what that means is we're going to find the other factors. So to get that, the reason I did synthetic division is because the polynomial I have that's left over, okay, 1 degree less, is now something that's quadratic. So what I can do now, if my goal is to factor, I can now factor this, which is a lot easier to factor. Okay, I would do 2 times negative 4, that gives me negative 8. Looking for numbers that multiply to negative 8 and add to negative 7. Those numbers are negative 8 and 1. So I keep the first term the same, and then I rewrite the middle, and I keep the last term the same. Then I do grouping. So out of those first 2 terms, I can take out 2x, which leaves me with x minus 4. Then on the next 2, I can take out a 1, leaves me with x minus 4. The parentheses match, and that's my other factor. So when I did division, I was left with a quadratic. That quadratic factors. Because 3 was a 0, x minus 3 was a factor. So this function has 3 factors. So the final factored form of that original equation is x minus 3, x minus 4, 2x plus 1. And we are going to spend more time doing this next class. This is really kind of an intro for you guys. But for now, the thing to really understand, if you do synthetic division with a number in the box, if you get 0 as an answer, that means that the number in the box is a 0. It also means that x minus that number is a factor.